Assalamualaikum warahmatullahi wabarakatuh, and everybody. Good day to everybody. So now we continue our this chapter in the centroid and center of gravity. So then our next topic is the composite body. So what's mean by composite? So composite means it consists of a series of connected simpler shaped bodies which may be rectangular, triangular, and or semicircular. So they have a consisting of a series that are connected together. Okay, a body can be sectioned or divided into its composite parts, accounting for finite number of weight. So this one generally to get this center of the gravity. So this one the differential, the total, the summing of the moment for each of the weight, each of the parts of the dividing by this dividing by the total weight. Same thing with the y bar, same thing for the z bar. So procedure of analysis the composite parts. The first one is the divide the body or object into a finite number of composite parts that have simpler shape. So now we're dividing all the body or object into the simpler shape. So treat the whole in composite as an additional composite part having a negative weight of sizes. So let's say we are cut out from the parts the whole, for example. So this one we taken into consideration, but we just put negative weight. So meaning negative we need to minus out from the total weight. So moment of R establish the coordinate axis and determine the coordinates of the center of gravity or center of each part. So we need to define the x and y axis. Okay, then summation determines the coordinates of the center of gravity by applying the center of gravity equation. If an object is symmetrical about an axis, the centroid of an object lies on the axis. If it is symmetrical about an axis, the centroid of the object lies on the axis. Okay, so now we have this area. So locate the centroid of the plate area here. So it's actually a composite. Why it's composite? Because this we can divide it into several parts. This one a triangle, this one is a big rectangle, this one is a small square here. Okay, so please divide it into three segments. The first one is a triangle, the second one is a square here, small rectangle. Then the small rectangle here considered as negative. So this one small rectangle here, because this one we are consider the full area, but we need to minus this area. So this one is a negative. So what we have, the segment 1, this one is a triangle. So the area is a half multiplied by the base multiplied by the height. So we get 4.5. Segment 2 is a square here. The area is the base multiplied by the height. So we have the 3 multiplied by 3, and then segment 3, sorry, segment 3, this one is a rectangle. So rectangle, so the base multiplied by the height. So what we have here, the area. Okay, so now because when the procedure we need to define our x and y. So let's say this what is the area for the segment 3 is negative, because this way when one cut out from this rectangle to make this this will can happen. Okay, so we're talking about x bar and y bar here. So for area 1, it's actually x bar is calculated from the origin x and y here 0, 0 to the point of the centroid of that particular area. So the centroid for the triangle is from this one is a centroid for triangle. So the location is calculated from this point to the x axis, this point to the y axis also. Okay, this point is as 1, 1. Okay, for this how we want to get this the centroid for this triangle. So you can refer back in our textbook Engineering Mechanics Static, written by the author is by the R.C. Hibbeler. So we can find it's actually the base dividing by 3, and also the height dividing by 3. you need to refer back into our formula. So that's why we get the 1. It's actually this point, and this point is calculated measuring from the y-axis is 1 for the x, and then this point calculated from the x-axis, so we get the 1 for y. Okay, this one is 1 1. For the segment 2 here, so this one is a little bit simple. This one is a square, so we just dividing by 2. 3 dividing by 2, so you get 1.5. So this one 1.5 also. So what we have, so 1.5, and this one is the centroid of this area. So now we want to calculate, we want to measure the centroid for area with respect to the x and y axis. So from this point to the y-axis we get 1.5. So the x bar is 1.5. From this point to the x-axis 1.5. So the y bar is 1.5. So but because this origin from here to this point is a negative direction for x, but from here to here is a positive direction for y. That's why x is negative. So that's why x is negative 1.5, y is 1.5 positive. So segment 3, this one the rectangle, just divided by 2, so we get this point of centroid for this rectangle. So the location of the location for the x centroid area with respect to the y and xy axis, need to measuring to the y axis, need to measuring the x axis. Please note that from this point origin 0 0 to this point is a negative x direction and also the positive y direction. That's why is a so negative in x, positive in y. So then we calculate the area here multiplied by the x bar, so we get the x bar e. So the area multiplied by y bar, so we get the y bar e. So same thing for the next two segments. Then we sum out all the total moment here, so we get negative 4 for this one. So we sum out the total moment here, we get 14 for this one. So we total up all these total areas, 11.5. So using the equation of centroid for S bar, so the total summation force, the summing moment x bar multiplied by E is negative 4, dividing by the total summation for the area is 11.5, we get a negative 0.348 mm. So I by the y bar, so 14 divided by 11.5, so we get 1.2 mm. So meaning that the x bar is a negative 0.388. So somewhere is here, and then for y bar is a 1.22. 1.22 is somewhere here. So this is a centroid of area. Okay, I think that's all for this chapter. If you really understand, for the centroid of area should be no problem. For the center of volume, center of gravity, and also the center of mass. So we are doing the tutorial in the next class. Then the next video is a remove the new chapter, new course actually we have done in the static. Now we have moved into the dynamic course. Okay, see you in dynamic class. See you again in next video, new course in the dynamic. Okay, see you, bye bye.